Good evening, friends. So, I hope all of you have been given some basic concepts of transmission line theory, right? Some idea you should have got while thinking about networks, transmission lines, right? And today we will see some more important concepts like why we need this theory, right? So if there is any technical issue like the screen is not sharing or audio is not there, I request Dr. Ashok to immediately give a feedback.
Yes, sir. Yes, sir. Yes, sir. I'm online. I'm looking after it, sir.
So today's topic is transmission line theory basics and what is the need for transmission line theory and how the electromagnetic wave is guided, and a few in-depth case of transverse EM waves, right? And if time permits, we will see a small interactive demonstration also. So as we all know, electronics is about the movement of electrons, storage of electrons, and radiation, right? And electrons are the driving force for every activity in Earth. And we can define electron as an energy packet, a source of energy, right? And it is also capable of doing any work. So, if an electron is accumulated in one point of a circuit, right, this gives rise to voltage. If the electron is flowing, it gives rise to current. And for electrons to flow, there should be an accumulation. Then only electron can flow, leading to current. Electrons oscillate, leading to waves. Electron transfer can lead to light generation. Electron emission can lead to heat generation. So everywhere if you see an electronic circuit, an electronic device, you deal with voltage, current, or wave. So normally, whenever we try to analyze a circuit, an electric circuit or electric network, we try to use only the voltage and current form of electron rather than wave. But the moment when we go to a transmission line, we try to introduce the concept of wave, right? In optoelectronics, we try to talk about electron transfer from one level or one level in a band to another band. We try to see the effect as light generation or photon generation. Similarly, electron emission can also lead to heat generation.
Sir, sorry for interruption. We are seeing slide number 2, sir.
So I am in slide number 2 only, I hope.
Okay, sir. Okay, sir. Just for confirmation, sir. Thank you.
So this slide is, the title is Basics Electrons. Am I correct?
Yes, sir. Yes, sir. Yes, sir.
Okay. So what I will do when I move, I will just tell the next slide and title also, so
Okay,
that time gap, right, we can adjust. So next topic, next slide is title is energy equal to electron hyphen wave. So energy is transferred from place to place by two means. Place means it signifies a point in a circuit, in a board, or it may be in space, right? So it is due to two means. One is current, flow of electrons through conductors from one point of the circuit to another point of the circuit, or it may be from one end of a component to another end of a component. It is current. Second option is by wave. Wave propagation in space. Wave propagation in a waveguide. Right? So in this case, the wave is guided in a guiding system or unguided system. Here